Hi, this is Marcus. This video builds on a talk I gave at the Superintelligence Conference at Exeter University in September 2025. For better understanding, I encourage you to pause or replay the video as needed. To start, in this talk, I claim broadly framing intelligence and entropy allows one to model general intelligence as a prelude to superintelligence. In defining intelligence, many views exist, even just for humans. But here, I explore human intelligence in relation to general intelligence, with human intelligence as our only way to consider general intelligence, but where the two are quite different. A simple view of intelligence starts with one's capacity for abstraction, the raw ability to have an idea, any idea. We next test that idea's value. How well does it fit material reality, the thing we gather intelligence on? Lastly, we store or memorize the results so we do not have to repeat prior tests, and which allows us to build intelligence over time. Despite many likely definitions, this simple view shows what I see as the most essential and most universal aspects of intelligence. Naming broad structural fundaments initiates a base for further study. For example, super, general, and human intelligence and beyond all point to various ways and degrees to which we recombine and grow these roles, all of which we experience today as intelligence. Next, general intelligence, to me, suggests an informatic ideal, a final goal for all of science. Perfect knowledge of the cosmos. We may never fully realize this ideal, but we can at least agree this is the main aim of science, to fully grasp the cosmos and its contents. But in pursuing that ideal, we see a problem. Our human lens is flawed, perhaps unequal to the challenge. For example, we know dark energy and dark matter fill 95% of the cosmos, but we know little more. Thus, in a simplistic way, we might say human knowledge covers only 5% of the known cosmos, and all the rest is logical gaps, where nature has no logical gaps. How we deal with our flaws is vital. By one count, mixed, subtle, and acute genomic and behavioral variants deny us true human universals for framing general intelligence, which makes modeling intelligence difficult. But in another way, that variety offers robustness. With 8.2 billion humans probing the cosmos, the chance we can glean useful insights is large, if we share and explore that experience with other humans. Informatic diversity and sociability boosts our capacity for general intelligence and makes information processing our main adaptive path. But despite notable gains, our mixed roles and logical gaps also mean we cannot mistake human intelligence for true general intelligence and perfect knowledge of the cosmos. Beyond partial general intelligence, all agents master an evolutionary arms race or expire. Competitive and cooperative facets exist for all agents and at all levels. Eternal genomic and behavioral adaptation shows as a still unfolding tree of life, with evolution by natural selection and many life-death entropic effects. In this arms race, human adaptation outruns other agents, with early superintelligent roles. This means some of us surpass what Earth and other agents natively manifest, with informatic creativity pushing us onward. For example, things like a pencil onto airplanes and spaceships are all supranatural effects, beyond what the bare Earth itself offers, informatically envisioned and selectively advanced for better survival, where nature's own creativity pushes us onward. In this way, we are now surrounded by many psychological fantasies made into some material form. Even tool use means someone somewhere invented that tool. In today's creative techno-cultural vastness, our only remaining fully natural role is that of our own body, while supranatural effects infuse all else about us. But creativity itself incites excess consumption, always attempting some new option beyond bare survival. This affects all agents in mixed ways as an adaptive impulse for eternal behavioral and reproductive growth. But in our own self-important, super-intelligent way, nature's eternal self-renewal seems to mean that the thing that gives birth to and nurtures us also seeks our ruin. We face this entropic mix with broken informatic tools that so far lead us to better survival. But we must also accept that our immediate human form is flawed, perhaps not the best nature can do, suggesting a future with sharp cultural shifts or even extinction. But for now, the effect of our mixed entropic strife is twofold. First, modeling general intelligence requires a contiguous view of diverse, simple to complex roles, along with shifting creativity and selection, but no logical gaps. Missing any step here bars finding a true general model, but still allows us to model singular aspects, as with today's ChatGPT and the like. Second, all manner of entropy inhabits our worldviews in science, tied to survival intelligence. For example, we often see entropy as signal and noise, life and death, order and chaos, and more, all tied to survival. If we cannot even survive as a base role, building adaptive intelligence seems absurd. But here, entropy is of special interest, as a likely formal core for intelligence modeling. Rudolf Clausius and Ludwig Boltzmann's thermodynamic entropy and statistical mechanics, and Claude Shannon's signal entropy, at times called the mother of all models, all arising from a likely cosmic singularity. Together they frame how things generally work and fall apart in the cosmos, as a bare common sense view of intelligence, and as an initial scientific view. But even this shows a logical gap. Both use the term entropy, but in opposed ways. Thermodynamic entropy reflects noise, the bane of all messages, but Shannon messages are themselves called signal entropy. One wonders what lies between these two entropic views and what connects them. Alternatively, they can be seen as cosmic bookends with shifting functional degrees of freedom filling the space between, to suggest a contiguous view of the cosmos and intelligence akin to nature's continuity. Claude Shannon and Warren Weaver likewise saw a missing theory of meaning offered a likely way forward. Okay, before going further, I recap what I cover so far. I first claim broadly framing intelligence and entropy precedes modeling superintelligence. I follow this with structural fundaments for intelligence. Next, I note problems tied to notions of general intelligence and human intelligence, along with mixed entropic roles. Lastly, from this I pose first principles for modeling intelligence, where such principles typically support scientific views by initially framing what is being modeled. The balance of this talk builds on these principles. In contrast, today's AI omits such principles to instead parse ever larger datasets on vast server farms with growing volumes of already baked human intelligence, but of mixed quality, including many logical gaps. To continue with modeling as a discipline, I now detail primitives tied to those principles. Scientific models shown here hold two roles. 1. Material primitives as objects holding matter's raw properties and traits. And 2. Logical primitives as object interactions or material logic of how matter behaves. These roles are plainly tied, but differ sharply in jointly supporting intelligence. For now, I label these roles object and subject. We can also state this reductively as two or more objects in synthesis typify all of material reality, and thus also typify all knowledge and intelligence. This OSO view of principles and primitives does 5 things. First, as noted, it holds a dual functional aspect, innate to material reality and agent experience, and to include in a later model. Second, it likewise poses dual symbols to use in contiguous modeling of material reality, experience, and intelligence, akin to alphabetic and numeric symbols in depicting the cosmos. Third, if tied to set scientific roles, it poses an overall serial structure for current and future science. Serial growth is a key aim here, with science forever reinvented and refined in a serial manner. This also roughly bridges prior gaps, while echoing nature's simple to complex expansion. Fourth, it maps a dualist triune fractal pattern as a likely computable core. Lastly, OSO syntax maps a general semantic effect that points to a larger general theory of meaning. A dual material aspect seems clear here, but can stir debate. Thus, to better see subject-object universality, consider a hammer and a nail. Objects held in isolation have no function. Only at the moment of a hammer striking a nail does a function truly arise. Before this, hammer and nail are just observed objects, but where object synthesis creates a semantic world. Still, synthesis exists only in that strike and is otherwise invisible. Moreover, years of practice afford more effective and efficient hammer-nail synthesis, or more intelligent work. For example, a nail can be driven quickly, or it may take many blows. A nail may be driven truly, or with glancing blows bending the nail. Objects exist or do not exist, but synthesis can vary widely. Synthesis can be sustained or instant, fine-grained or coarse, creative or destructive, and with subtle onto acute phase transitions, all of which must be mapped to fully model material reality and general intelligence. As such, subject and object each jointly and separately drive material reality and intelligence, which can confuse some people. Add to this mixed entropic roles, and sharp debates can follow. But a firm grasp of this dual material aspect is key to moving forward. For example, the standard model shows a fine-tuned universe of exactly balanced constants and laws, where low synthetic variety allows the cosmos to exist, a credible object-oriented science. In contrast, natural selection, as our most successful scientific model, seems chaotic, but with firm common-sense views of subjective survival. Simple to complex synthetic variety has many faces that Darwin intuitively mapped in a powerful common-sense way. These views differ sharply. One, the epitome of pure objectivity, the other, the epitome of subjective survival, but both scientific and tied to nature. Still, Darwin's intuitive diversity collides with the standard model's measurable and repeatable structure, but poor common sense with basics like gravity, and life. We can add to this the periodic table's mild synthetic variety of 94 elements, onto myriad diverse molecules, again with uneven common sense. Broken scientific facets do not make these models bad, but highlight the fact that logical gaps abound. Conversely, universal subject-object roles offer a contiguous bridge to cover all such gaps, alongside accepted scientific roles. S and O, informatic principles and primitives, support a full map of all material reality and all intelligence, as suggested with this simplistic graph. This graph is firmly bound at one end by object properties and traits of low synthetic variety. It holds one type of object intelligence as regular functions. But traversing a simple to complex cosmos holds expansive object synthesis as a second type of intelligence that is creatively ambiguous. In this second aspect, synthetic variety, common sense, entropy, adaptive functioning, and survival are all closely linked. But overall, they jointly mark a paradoxic, bounded yet ambiguous solution space, mastery of which is the main task of any intelligent agent. Okay, at this point we are near 16 minutes into this talk, and we now have a bare model for a science of superintelligence. But much lies ahead in fully mapping the what, where, why, and how of subject and object shifts and supernatural gains or superintelligence. Still, the graph before you recaps the study so far, where one can envision the direction of further analysis. But for now, I will stop here and later develop Part 2 and Part 3 videos for this talk. Lastly, I suggest you also see my initial talk, The Advent of Superintelligence, for another view. Okay, that is all for now, and I thank you for your attention so far.